Remember the old Star Trek series?
No.
Yeah.
You don't? Oh yeah. Well, me and Jason are Trekkies more than anybody, I guess. But yeah, there was one called The Changeling, and it was one of my favorites actually. And
It's a classic.
it was like I guess you could call it a robot, but it was a very
It was a
dangerous
probe.
robot,
Like
a probe. A probe that was launched from Earth that ran into some thing, and it turned it into like a real bad thing. Anyway,
Well, I guess it's like the motion picture.
the old original Star Trek series, The Changeling. But anyway, Nomad was a badass robot, right?
No.
But anyway, he had problems with data, or is it data?
Okay.
Let's say data, because then we're going to confuse it with data
That's
from
right,
the
that's
newer Star. So he had issues with data, which actually was his downfall, and that's how they took him out.
Uh-huh.
Yeah,
Wow.
yeah, because otherwise he could have wiped out the whole planets. He was powerful.
Mm-hmm.
Yeah, he had things.
And they blew him up with just some simple words.
He fried O'Hara's mind, and he did all kinds of
There's a
things. He
really
could do
great
anything.
intro.
He could fix things with an antenna. Anyway,
Okay.
anyway,
the thing
yeah.
was, though, it was a product of its time because it was a problem at the time
Yeah.
with computers.
Yeah.
You know, sending them faulty information.
Faulty data,
Yeah.
errors. Yeah, just
Yeah.
like trying to get to the moon with a bunch of switches and whatever crude computers they had at the time. Can you
So
imagine?
anyways,
Yeah.
Yes.
it is a common thing people say online that all data is good data. The more data, the better. And I think there's some truth to that, but it's also dramatically more complex to that. Because is all data actually useful for most people? Especially when they don't tell you what tools were used to generate the data, how it was measured, how this data was generated and evaluated. Because there's a lot of nuance to it, and it's an important discussion here.
What also matters, not only the raw data, but usually you're comparing it to something. So are they
Mhm.
both done with the same procedures and all that, So there's a lot of complexity that can happen.
You'll see manufacturers, let's say 2 times faster, 10 times faster. And a lot of times they're not that clear on what they mean by that. Faster than what? When? Am I going to notice it? Does it even matter? Because you'll hit realistic limits where it's already fast enough where I don't notice it loading or anything like that. So it doesn't matter it's even 10 times faster. Because maybe it is. But is that useful to me?
Well, not only that, you cherry pick where your product looks the best, right?
Right.
So
So
then
is
you
it
post
actually,
that.
right, is it a useful metric to say it's 2 times faster? And I think there's a lot of applications here that are kind of give relevant insight.
Well, you think about it when you talk about any kind of marketing that we're hit with or barraged with on a semi-minute by minute basis.
Quite
If
often.
you're online, I mean everything. I guess when you look at it, a lot of it tries to throw some sort of data your way, and and the question is, how is it generated, right? And I mean, it could be a number, it could be words, it could be anything. My hands are softer than yours because I use this lotion, or wow, look at my hair with this shampoo, or
Oh,
look at how
There's a
this
whole
iron
different thing,
irons
though.
a shirt, or
because it could not even be. It could be disguised as data, right? That's another thing.
Right.
It's like they want you to think this is the specifications, but then you look at the specs and it's completely different.
Yeah.
So it's like your car amplifiers back in the day, right? They would say 5,000 W.
Yeah.
Right? But you look at the spec, it's 120 watts, right?
yeah.
There
They
was a
want you
thing
to
for a
think
long
it was
time.
5,000 watts.
It's not
right?
5,000 watts.
Right.
They'll tell you it was just 5,000 Ws,
Right.
not watts.
Now, the way I always knew that is the size of the fuse that it
Well, you
took.
always can
Yeah.
tell that. It's like, well, it's not
It's like,
physically
well, if it can't
possible.
blow this,
Yeah,
it
right.
sure as hell ain't going that
Right.
high.
They'll rate it like if you short the main storage capacitor, you could get 5,000 watt peaks for a femtosecond or
Yeah,
something.
just before it smokes.
But you're not going to
Yeah.
get 5,000 watts of amplification out this thing.
Yeah.
Yeah.
So yeah, it could be something like that where it maybe even could do the 5,000 watts.
In some
but you're
unrealistic
thinking
situation.
sustained that's what they want you to think. It could
You
do
interpret it
sustained.
differently than the reality.
Yeah.
And that is the issue with these things. So I do agree that data is great, data is useful, but it's ironic to some extent that a lot of people are extremely pro measurement. They say the measurements will, they'll fix the issues with the marketing dilemma. They'll make sure that you know the truth, and rather than hearing whatever marketing gimmicks that somebody's trying to sell you. And I agree with that. However, there's a lot you could do to lie with the data, things like that, right?
Well, like we see that all the time with with reviewers and their measurements and so on, and each one of them has a different rig or basically a different device for making measurements. So, and when you're dealing with acoustics, that matters. And when you're dealing with placement of acoustics making a difference in the raw data you get, that matters a lot more. So basically, you could, I guess the way to explain that, you could, let's say you took a headphone, whatever it is, and the same headphone went to 10 reviewers who make measurements. Each one of them would have a different set of data when they're done. Same headphone.
To some extent, sure.
Guaranteed. And the only way they can line up is if they had an exact same methodology to setting up that particular headphone
And same
on
equipment.
that test set and the same gear. Otherwise, every piece of that, every one of those guys or gals or whoever's making the measurements would have a different set of data. And you think about that, it's like so okay, if that being said, whose data is more relevant or right or
That's
wrong?
the issue, right?
How do you know? How do you know at the other side of it that the people that don't make measurements, who have no idea how it's done because it's like black magic, so to speak, right? You don't know how you just see this chart. Well, how'd you get it? Maybe people should ask that. Like, where'd that come from?
That's the important thing.
Where'd you get the data from? How did you do it?
It should be a question people ask.
Yeah.
Because if you have two measurements for the same headphone, let's say it's literally exactly the same headphone taken days apart in different rigs, how do you know which one's right? And that's a genuine, honest question. How do you know? Ideally, there's testing methodology that would give you sufficient confidence to know that your measurement is reasonably accurate. But the truth is that isn't always happening. You don't know, looking at the data, how the data was generated oftentimes. You don't know, you can't verify beyond the shadow of a doubt usually that this data is valid. And you really don't have the data to know if the data is correct.
Yeah, I mean, even the things like, even if you're using the same gear, let's say you use exactly the same system, but the settings are different.
There's a million ways you could
Well,
lie.
or if
Sure.
it's just sitting out on a desk, right?
Yeah.
They're all in
Oh,
different environments, different
Right.
ambient
Electrical
noises,
noise,
any
ambient
kind of
noise.
things,
Yeah, right.
So
Yeah, I mean, and that skews the data.
And this goes well beyond headphones, of course. This applies for everything. The question isn't whether or not you have to trust the reviewer. It's just, do they know? Do they go through the effort to ensure that their rig is better than everyone else's, so their rig measures perfectly? Have they verified this? Do they have other headphones come in? Do they compare measurements between several other similar rigs?
We
And
probably should
these
stop
things
using the
matter.
word rig because actually people could confuse that with the playback chain as being.
Okay,
Yeah,
The headphone measurement
Yeah,
system.
we need the
apparatus.
measurement system.
There you
Yeah,
go.
because it is confusing, and
Yeah.
we don't use the terminology as confusing as it is.
But here's
So,
a relevant example. One I think people dealt with on a daily basis. You look at the outdoor temperature measurement in a car, and that's one that I commonly have a gripe with. A lot of cars will give you measurements that are very wrong. And it's not because the sensor data is wrong. It's not because they don't have the data. They do. It's because of the influences, because of other factors. And the algorithm that they have to determine the temperature is flawed oftentimes. You'll see people taking screenshots of their car temperature and saying, wow, look, it's saying 140 or something like that, 120. And the actual weather says it's, if you pull up an app on your phone or something, you look at the weather channel, it'll say 93. So why is it saying a 20 degree, 30 degree difference?
And
this
some
happens-
cars.
Yeah, some cars. It's common, and you'll get wild variation.
I always wonder, like, how the hell they put the sensor in there
Where
so
do you
it's
put
so
it?
it's not right because
Right.
I mean in the front you got engine
Yeah.
heat.
You got the
You
exhaust. You got all kinds of factors.
sun beating down. Different color cars will
underneath doesn't
absorb.
work either though
Right.
in the middle because like you got radiant heat off the asphalt and everything.
Do you have any idea where
so-
the hell they even put them? I have no idea.
Overwhelmingly, it's in the front of the car.
Yeah.
Usually, it's in front of the radiator in the grill area. Usually,
Seriously?
the lower grill area.
So they're trying to get air blowing in
Fresh
as
air.
you're moving.
But because of this, they know the sensor data is only accurate when the car is in motion at a reasonable enough speed. And because of that, they'll ignore the sensor readings for long spans of time. And a lot of cars, if the car is parked and the engine is warm, they will entirely ignore the sensor data for 10 to 20 minutes in occasion after the car started. So the first 5 minutes you were running the car, the number it's telling you was what it estimates based on the past temperature the car was. Or you have it in a garage and you'll see the numbers go down very slowly if it's colder outside.
That's true. Like
It's
the one,
because it's extrapolating.
my wife's car, the Macan.
Yeah.
It seems to like slowly update. Like
All cars do that.
out of
yeah.
nowhere, it's a different temperature. It could be, I don't know how long. I never looked at it,
Takes
but
a
yeah, it
long
seems like
time.
it's always
Yeah, it
stuck on
depends
one
on the
number,
vehicle.
even though I know it's not that number.
And pay attention to this. If
you
you
know?
park it in a garage and it's colder outside, or if it's warmer, you'll notice the temperature change slowly. This is not the sensor data changing slowly. This is the algorithm accounting for the circumstances because it's trying to predict the actual temperature and it's running through an algorithm.
So then
to
what's
do
the
that.
right temperature?
So that's the issue, right? And if you told people the sensor data, you might think, well, that's the truth. That's the actual number. That's not true either.
I guess
There's
what
all
they're-
kinds of calibration factors and reasons.
What they're
to do that.
gambling on that, though, when you think about it, is the fact that as you're driving along in any street,
At
the
some point, it's right.
the temperature doesn't really vary.
Right.
It's when you park the car and get out, get back in. That's when
Or
things
if you
get
stop
wrong.
at a light, now you have hot air from the radiator potentially
That's
blowing,
true.
depending on wind conditions.
Yeah.
And if the fans turn on,
Well,
you could get turbulence
So,
that causes.
so technically, you could say what the car is doing in order to not have that issues like that is it's throwing out a majority of the data.
It's
just
lying,
It's
yeah.
not showing you it, which is in a way the way they're smoothing it. They're
Right.
smoothing the data.
So the question is
results.
all data good data? Because it has more data than it's showing you. It has a lot of data. It doesn't show you most of the data because it assumes it's wrong, but it doesn't know. It's not smart enough to know.
Yeah, I was thinking about this the other day actually, and like obviously your like your phone battery indicator lies to you all
Yep.
the time. Because like if it was truthful, you take it off the charger, it should be ready 99.999. Like
Right.
if they put like 4 decimals of like resolution on it,
That'd be mad.
it should never say 100. As soon as you take it off and this plays on, it should be dropping. But it says 100 for
A long time, a
while.
lot of times, yeah.
So,
Well, the
why
reality
is
of it
that?
is the reality of it is we as humans don't need that kind of resolution.
yeah, but I would like it.
to see. I wouldn't. Me, I'm actually 1 to 100 is more than adequate for me. In fact, I could probably divvy that down to 1 to 10, and I'd be good with that.
Well, 'cause you
When
know
I'm,
it's
if
like,
I'm if
it's
I'm
not
at
100
3
then.
or 2 or 1, a 10%, number, I'd be okay with that.
10%?
I would learn to understand that when it gets to 2%, I'm at 20% or 2. I mean, the number
yeah.
2. Just go by 10. I don't need graduations that much. And I think, when you think about it, it's the same with our sight, our hearing, like, for example, let's look at like motion pictures, right? Back in the day when they had film, right? They had to do
still
so many
do.
frames per second, but the frame, they were actually stills to create moving images that the brain interpreted as motion, smooth motion. And I don't know what the number is, 16? What's the minimum I forget
Yeah,
what it
something
was.
in the teens, like-
You got to get above what the brain sampling rate is, and then now it looks smoother to you. And of course, now we noticed you could see 30 hertz flicker on a certain lighting, right? Where 60
Sure,
it goes
absolutely.
away, 50 you could even see sometimes. So yeah, so I mean, when you think about that, right? Consider that data points, right? You don't at some point. We as humans don't need any more. Right.
Right.
You don't notice the difference
Well, in
because
video-
your brain smooths it out for you, or your whatever it is.
That's a huge range in video though, because like it might be in like 16, 17 where it's like kind of looks like motion, but you could see the difference up to 150.
Oh, really?
Oh yeah,
Yeah. Oh, you mean with like fast moving, like
Yeah, yeah,
gaming
yeah.
and stuff.
But
like
it's
that.
highly dependent on what's showing. And that's
Right.
Well,
part of the
yeah.
issue. There's some subjectivity to it. So it could be like we're recording this at 24 FPS, and it looks reasonably smooth,
Yeah.
for the most part. It's not butter, but it's reasonably smooth. You would call it video for the most part, I would imagine. 24 FPS being one of the most common frame rates out there. However, in gaming, 24 FPS is a clip show, right?
Oh,
It
yeah.
looks like every frame's
Yeah, yeah.
coming at you like that, right?
You literally can't win.
But that's because you're interfacing with it. You're manipulating the image. So your brain is wondering, why when I move the mouse do I not see motion for some period of time?
Oh, and there's delays involved too.
There's a delay, yeah,
Ah,
right.
Right.
So it's like a whole system.
It's not only you delaying;
Yeah,
it's
yeah.
the damn computer delaying when you move the mouse.
So sometimes 24 FPS is fine,
Yeah.
but in gaming, that's horrific.
Right.
Even 60 FPS is kind of slow in
Plus, you
gaming.
got the delay of if you're on Wi-Fi, you shouldn't be. Don't be on Wi-Fi. Yeah, you got internet delay and everything. So
Right.
I mean,
it all piles
adds
up.
Yeah.
So there's always this question, is it good enough? Does it matter? Because sometimes people will sell you, well, this does this better. Maybe it even does. But does it honestly matter? Because you got to assume if someone's telling you data or measurement, they have some incentive to do so. It could be they want you to subscribe to the channel. They want you to watch what they do. It could be they want you to click a link in the description to make some trivial percentage on a sale. It could be they want to sell you their product, right? So it depends on where the measurements are. You got to take this into account. What incentive do they have to show you this data? Does it should it be trusted?
Is a Cat
Doesn't
7
matter.
cable better than a Cat 6 cable in your application?
Like you could put a Cat 7 cable in, great.
Yeah,
It's a better cable, but it won't do anything in almost every modern situation.
Although it does feel good to have a Cat
Kind
7.
of, right?
Well, I like the metal
Yeah.
Or a
connectors.
6A or something like that, not
Yeah.
not a 5.
You get
or,
a nice Cat 6A
know,
with the little shield.
You kind of know that,
okay.
okay, it's probably not going to be, assuming it was made properly,
Yeah.
it's probably not going to be an issue here. If I have an issue,
Right.
I can ignore that.
You get to question those flat cables, you know, the flat Ethernet cables.
Yeah, well, yeah.
It's like, did these meet spec?
Well, they're really just twisted pairs. Four
Still
twisted
seems
pairs
sketchy,
going
though.
side by side
Yeah.
instead of around each
Yeah.
other, which, yeah, it's
That's
still
not spec.
yeah.
A little questionable.
Yeah, that is a
Yeah.
little questionable.
Yeah.
Yeah. Any flat cable. They used to have phone cables with 4 conductors used to be kind of flat, which is kind of scary.
Yeah, a little bit different bandwidth.
Yeah,
requirements.
right.
Just a little bit. Plus, they were sitting in a home environment, so it wasn't bad.
Yeah.
But as soon as they left your house, they had to be twisted.
But it's exactly that. In most applications, Cat 5e is sufficient. Maybe Cat 6. But you'll see people online saying, I got a Cat 7 cable. Read the reviews on Amazon.
Oh, yeah.
I got this Cat 7 cable, and wow, my internet speed so massively improved. But the cable, you could test it. It's capable of doing gigabit, 10 gigabit, maybe even 25 gigabit in some circumstances and lengths. And yet people will say my 100 megabit internet is somehow faster replacing my Cat 6 cable with a Cat 7.
No,
The data doesn't say it's likely to occur, and in fact, it
well,
probably
it's
is
quite
faster, but it's
possible that,
perceptual,
that
right?
the data given doesn't encompass everything that's going on there. Like, you could look at speed as one measurement factor, but what about noise? How does that play into it? And it varies by device and environment. So,
Yeah.
noise is a factor that no one really measures in cables, because how do you do that? You'd have to bombard the cable with an artificial noise, which doesn't really encompass. It's not all encompassing in the real world.
I ran into a cable that was like, Ethernet cable that was like not meeting spec at all one time.
Yeah.
So I cut the ends off, and I found out why. It was just all the wires in a tube. None of them were twisted.
Oh, jeez.
Yeah. So
That
it was
happens.
Just
yeah.
straight.
Yeah, just wires in a tube, just sitting there.
Oh,
Yeah.
man.
Probably a copper-clad aluminum
Talk about
conductors.
lack of.
So yeah, I'm like, why is this not going as fast as it should be?
Yeah, because I mean, when you get to higher speeds, RF frequencies, you're dealing with not just. It's not just noise; it's also impedance of the cable, the line. If it changes impedance along its length, it sets up bottlenecks for higher frequencies to bounce around and skew the data.
Another fair, relevant observation that's a common issue, Wi-Fi. So in CanJam, we had a lot of issues with wireless, the internet, and stuff like that. And it's not a physical bandwidth limitation. It's not even necessarily a Wi-Fi limitation. Most likely, it was just the sheer number of clients that were on there. The number of users, devices that were on the network were causing a physical limitation, because there is only so much airspace, as they call it. There's only so much available spectrum to transmit the information. If there's more devices, you're sharing it more with other people, because you can't really talk at the same time. So if you have 100 devices, this one device is limited by all the other devices.
But
There's
I bet,
only so much you
I
can
bet
do.
when they got the router for that big ballroom area,
Yeah.
it probably gave them a number. of-
Yeah, it'll do
they can
500
handle.
clients.
Yeah,
It
that-
could, maybe.
And they're like, oh, that's more than adequate than
Yeah.
any vendor number. But but when it boils down to it, it totally depends on the
In
bandwidth
practice, does it actually
that
achieve
every
that?
one of them is drawn. Is
Because I have
using.
no doubt the numbers they say on the boxes for routers, wireless routers and modems and stuff, they probably are achievable in some unrealistic situation. But does it matter? Is it better? Can you get that? And can you get that in a noisy
I mean, we kind of
environment?
know just from a home environment. I mean,
Yeah, you never
the
see that.
shitty routers we're stuck with buying because that's kind of what you get.
They say
You know,
2.6 gigabit.
you start
Great.
getting-
Well,
you
you
can
never
see-
get that.
Yeah.
They prioritize different numbers that they advertise
Yeah.
between the consumer and professional space and routers. Because like for consumers, they're always pushing maximum bandwidth, right?
Right.
Speed.
It's one number.
Right.
They
Like-
don't never
like
talk
that's
about
gonna be a
number
real-
of clients,
real
right?
thing.
And that they're
Yeah.
not good at that either.
No.
Like the consumer stuff. But when you talk about like pro route, like any kind of pro,
Yeah.
Wireless
commercial.
access
wireless
point.
access point,
Commercial.
Yeah.
that's all they talk about is clients, number of clients,
Yeah,
500,000 clients, because that's all that
Well,
really
somewhere
matters.
along the way in that number, they're averaging the amount of data that each one of these clients would utilize.
Right. They tell
and
you the
coming up
test
with a
data, right?
number.
But
Yeah.
it's not always realistic to your workload. You need to understand, like at CanJam, we have 50, 100 vendors or something like that with separate iPads or some sort of computers
Some
or
are running
laptops.
10 of them at
Yeah,
per
right.
vendor.
And they're
you know?
streaming music, but high bitrate music.
Yeah.
So it could be that they're trying to stay lossless or beyond conventional CD quality at all these devices. So it could be one wireless access point is trying to handle 200 clients simultaneously streaming high bitrate content. And that's an absurdly unrealistic workload for most metrics.
Yeah, and we could go on and on about this because obviously
yeah.
it's an issue for anywhere. There's a lot of people, cellular networks,
Well,
everything, anything that has to do with data.
I mean,
you know,
there's plus all the devices aren't all on the same band. You know, you got different, older devices, newer devices.
but the question is, how is this all relevant to the average consumer? Like most people could give a shit about that, right? They're like, if they either know it's black and white to them. It either works or it don't.
Right.
Right. I mean, that all that in between is irrelevant data to the average person because they're like, they don't know why it ain't working. They just know it don't work, or it does.
Yep.
And it's the same with like reading it, like you said, reading a temperature car. It's only relevant when you open a door and go, shit, it's way hotter than I thought, or it's way colder out here than it said. It's only relevant when it affects you. And I mean, that's a whole different discussion altogether, I guess.
It's trying to give you data that you think you want to know. And you always need to question whether or not it's accurate, whether or not it's right, whether or not it matters. That's the important thing, because sometimes
some guy
it
had to
honestly
design
doesn't.
it to do that.
Well, it is true because as for routers, that's why they don't tell it. Because who would care in a house if it could handle 500 clients? You're
doesn't
never
matter,
gonna
right?
run
They
into
don't
it.
even tell
They
you.
don't- they don't-
Yeah.
That's why they don't tell you.
You basically think you're spending more than you have to
Yeah,
because
right.
I don't have 500 anything in my
Yeah.
house.
But this data could be manipulated a number of ways. So all data isn't always useful. And in a lot of ways, you could have a data point that's misleading because it makes people think the product is better than it is. That's common to see in marketing. And it could be truthful, but it could also be misleading.
Well, we've brought up like dyno measurements of cars too. It's the same deal, you know.
Oh, yeah.
It tells you a peak number.
Yeah, and I mean it's way better when you could see the curve, the torque and horsepower curves to understand. But then you still got to understand what that's telling you.
Well, yeah.
Right? I mean, because you got to relate that to how it feels when you're driving a
Right.
car.
Does
You'd
it
have
feel
to-
fast?
Yeah, you'd have to know like how each one of those points on a graph feel in different automobiles, and it's kind of tricky.
Well, and you got the other thing of like people know like compared to everybody else's dyno, this dyno always reads high, and some people prefer that so then they get a bigger number.
That's like the doctor's
yeah.
office with the blood pressure machines. They
I got-
always read high.
Yeah, it's like I got 1,000 horsepower on this specific dyno.
Yeah, but do you
Anywhere else
really?
I go, it's like 857 or something. But
Right. That's
you
one of
prefer
my
that.
issues with measurements. You would think that measurements should set out to seek the truth. And sometimes they do, but overwhelmingly they don't. And it's not necessarily malicious. It's just because they don't have the resources at hand to know the absolute truth, because it's very difficult in a lot of cases to know what is the actual temperature.
I remember when we first got, we've got the B&K, the 5128 test head for headphones, and the Audio Precision. It's basically it interfaces the head. It's a headphone amplifier, interfaces to the PC, and the software goes with it, and all that for measuring headphones. Right? First got that, and I'm like, well, I could figure out how to set this up, but it's probably going to take me a freaking month. So Jude from HeadFi already had one of these. He's had it a number of years prior to us, and he had it set up for what he was using it. And so I just gave him a call, and we quickly went through the settings. I understand how to make measurements, but I didn't know how to set this device up. So bam, set up, ready to go, did some test measurements, did hundreds of more test measurements, right? Started to feel comfortable with how it works. So then I said, all right, well, I had to send you to Diana TC. I think it was this was a while back. So TC just came out. I got to send him one to play with, right, for the video. So I'm like, well, while I'm at it, I'm going to measure this Diana TC best I can on our test head rig. And then he's got the same setup. Send him the headphone, let him measure it to see if we should get pretty damn near measurements if we're doing the same thing. Mm-hmm. And ultimately we did. And that was like kind of a way to verify that we're both doing similar things with the same test rig, because if one of us was off, like me, I expected me to be off further than I was, and I wasn't. I was good because he had more experience with using it. But I have more experience with our headphone only, making measurements over and over again. So I guess you could say with that one headphone, I could ramp up a lot faster while he's doing 1,000 headphones, and everyone's a learning curve, right? So
well, I remember it's the same thing. Like they tried for like weights and measure standards. Like they gave everybody the same exact weight, and they sent them all around the world. And then every once in a while, they'd bring them all back and measure them all to see if
Oh
they all
yeah,
were the
right,
same.
right.
But then they started to drift from each other, and everybody's
Yeah.
like, "Oh, well, this isn't great, right?" So they had to come up with an entirely new standard because it's like, "Well, this doesn't."
I think
work.
Veritasium had a video on
I
that.
think
It was pretty
him that
lengthy,
did a video.
but it's basically that problem, right? Because the whole thing is like you need to know weights relatively accurately. That's an important thing. So they made a standard, and they said, "Well, we know this is exactly 1 kilogram because we define the kilogram as what this weighs. So even if it changes weight, this is still 1 kilogram."
right.
Right. And then they made standards referenced off that they say, well, these are very, very, very close to this standard. And they ship those out and they say, you set your numbers to this. And then, of course, it keeps going down the line. So the scale you buy is based off a measurement, off a measurement, off a measurement. And you hope it's right, but you don't really know.
Well, back in the day, that's how they used to weigh gold, right? They had a balance for a scale,
yeah.
and they had known weights,
Right.
and you could see how easy it'd be to cheat
Well,
on that.
yeah.
Of course.
You just shave some off the known weight, and now everyone's getting ripped off.
Yeah.
So the thing about data is there's always some level of uncertainty, and you hope that you know enough about the measurement system and the way you're doing things that you understand the uncertainty. And my hope is that people would advertise this uncertainty. So that's to some extent what you would do when you see a temperature measurement and it only gives you 1 degree resolution. Because the truth is, they don't even know if it's that close, right? So they give you
Right.
1 degree because they're not going to tell you, oh, it's 23.4897 degrees, because they don't know, right?
I mean,
There's
it could
uncertainty.
tell you that.
It
but
could.
It's just as inaccurate.
Internally,
still.
it may have that type of resolution,
yeah.
but they don't tell you because they're not confident enough.
Well, it's not only it's not only that factor, but it's also when you look if they don't maybe they don't have to tell you what's missing, but they need to explain to you what it is you're seeing.
Yeah.
I mean, that's just as important, right? All right, maybe it's good to understand the limitations. I mean, that should be kind of defined somehow.
yes.
But for someone who doesn't do this for a living or doesn't make the measurement, it'd be nice for someone, a reviewer or whatever, to explain it. Like, what does this mean? You know, and the problem there is, then they need to also understand what it means too. And a lot of them don't, because they didn't make the part that they're measuring. Right? I mean, how do you explain that so that people understand it, so it makes sense? We see it all the time. People show a measurement, but they don't necessarily know how it's defined.
Well, people will blindly repost measurements. And there isn't necessarily anything wrong with that. But a lot of times people seeing the measurement don't understand the nuance. So they'll take it verbatim, exactly as it's shown. They'll say, well, this one's closer to some target than another. And that may be better, but it may not. From the measurement alone, it's really hard to know.
Well, I mean, you kind of potentially lose context because maybe everybody in like a specific thread or wherever you posted
Right.
initially knew the setup that was used.
Right.
But then you just take it and plop it somewhere else and only have a chart, then you don't know anymore, right?
Yeah.
Yeah.
So it's
It's
kind of like
difficult.
there's no like citation. There's no like, nobody's like posting like a nice block underneath that says, oh, this is why all this is like this and what equipment's used and all
Yeah.
that.
Oh, I do think we need to clarify. In this sense, I think we're talking in an absolute sense, which tends to be my preferred approach. And what I mean by that is nobody knows. Literally nobody in the world knows. There's people with more confidence and there's people with less confidence,
True.
but nobody knows.
Well, that's why my previous power supply on my computer, I would always question it because you go into
Yeah.
BIOS and it'll tell you the rail voltages of the power supply. And the other one, it's like 3.367, whatever. But the 12-volt rail always, every time said 12.000. I'm like, no way.
There's no effing way.
every time I turn it's not like one time it's always says 3
Right.
digits it's giving you
Now that's
zero.
unlikely.
that's
And I'm
quite
like,
that's quite the algorithm going
No
on there.
way.
Yeah,
No
right.
way.
Right.
Right.
It's not really measuring.
Yeah, apparently.
You look at actual
It's
test
close
data,
enough.
It's never,
Yeah, right.
it's never 12
Yeah, right.
except that one
Well,
point.
not out to
It's
3 decimals. Jesus, there's just no
Yeah.
way as well. You could just put your finger on the trace and it
So
should
it's
go
why
up.
I always
0.01.
question that power supply or the motherboard. I don't know, whatever. And it's like,
That's crazy.
so I don't like this inaccurate
Yeah.
data
Well.
thing. It's just that's why it bothers me with the battery on your phone because I know that's not right, right?
Yeah,
Well,
it
they-
says
That's why-
100,
you're
but
right,
it's not.
Yeah.
It's not.
Yeah.
Well, they
I get
obviously.
it. If it's off 1%, why does it matter?
Yeah.
But still, it's
Well, they
wrong.
threw it out 3 decimals, but it's actually only going to change if it varies by 0.1 volt
Right,
or something like that.
probably.
It just doesn't move.
They don't
You
tell
know?
you that, though.
Yeah, right.
Yeah.
Yeah. Well, they really should have got rid of the decimal points, but hey, it was probably more work to set the damn display up to not have three
Well,
places.
it doesn't really matter.
Yeah, it doesn't matter.
Yeah.
It's a computer.
Or
so it's not
whatever the
monitor.
measurement device is. I know you would think it wouldn't matter, but
Yeah.
see, that's resolution.
Yeah.
You know, the 12-volt line,
Well, it's the
whatever's
illusion
measuring
of-
it,
it's the
requires
illusion of
more.
resolution is what
What's
it
it?
Well, there's resolution and precision.
That's
Yeah.
right.
They're not
Okay.
the same.
All right.
That's right.
All right. True.
Yeah. Yeah,
True.
you could keep adding decimal
The
places.
decimal place
but-
gives you a perception of what the resolution is.
Right.
But
But it doesn't actually necessarily.
doesn't really
right?
mean
you
that that's the
hope
resolution.
that somebody
It's true.
made a conscious decision when they tell you the number of decimal places that these actually work. They matter.
Well, it's just kind of like
They may not.
a digital voltmeter, right? Is the same deal, right? Most of them go out, what, 3 places or so.
That's like the
Depends
low
on the
end,
voltage
but
range.
yeah.
But it doesn't mean they're accurate out to 3 places.
It does
Well,
not.
they give you specs for that.
Most of them are like, what, at least a couple percent. It goes by a percent.
Yeah.
And 1%'s good. And I mean, if you're reading 100 volts, that's 1 volt.
Right.
Well,
You know,
it gets
that's on the good side of.
because you get to 8.5 digit precision multimeters, and then everything matters, right?
Yeah, right.
You start
You
talking.
pay for the lab grade
Yeah.
stuff, but yeah.
Get 3 multimeters, different brands, different models. Hell, get the same brand as
Same
model.
Yeah, there you
same
go.
brand.
Measure the same thing. They all will probably have a different number.
Out to so many digits, yeah, they'll
Probably.
be different. Yeah,
And which one's right?
yeah.
That's
Because the
difficulty.
calibration only gets so good.
Yeah.
So anyway, I think everyone gets the idea.
Well, yeah. I mean,
Just gotta
especially
think
with
about it.
go look at some test equipment videos on the internet, and you'll see
Yeah.
everybody that has worked with test equipment for a long time all are like, it's within spec. Throw some- like that's what it is. I mean, that's the best you can do,
Right.
right? It's within 1%.
Yeah, go watch some single path videos
Oh,
or
yeah,
EV
signal path.
blog.
Yeah.
Yeah,
Yeah, they'll show you some stuff.
Yeah.
yeah. There you go.
That's the way to go.
Yeah, and then you'll know way more about data
Things
than
are very
you
difficult.
ever want to know in your lifetime.
Yeah.
Boy, we covered that. I mean, we could
Yeah.
talk about this.
Yeah,
for-
well, yeah.
We could go in depth, you name it, because we've
Right.
all dealt with bad data.
Right, it's not like this is an attack on anyone or something. I'm
Yeah.
sure people are going to say it is, but it's just the reality.
Well,
Is
bad
peop-
data is a real bitch.
It's a complicated thing, right? And a
You
lot of
should-
people don't understand
I
it.
mean, you should strive to eliminate it. Is really what it comes down to.
right.
And I guess that's also not to say that we understand it, but we know that
Yeah.
measurements aren't always to be trusted.
Yeah.
Oh yeah. I mean, I got tricked before with bad data. You know,
course.
you're like you measure something wrong, or you
Yeah.
know, you don't scrape off an oxide layer on a contact.
Well,
the numbers wrong.
this is where experience comes in.
Yeah.
The experience allows you to foresee the problems that occur when you make measurements that, you can avoid it up front. You already did all that.
Right.
You knew that you had to clean the content.
Yeah, yeah.
You knew that. You knew this. Where someone who just started doing the measurements would run into shit like that and just go
Oh,
with it.
This is it.
Yeah,
Yeah.
there's the measurement.
There it is.
I measured it.
I saw
We're
you
good.
running into it too. It's like you break out your multimeter and you're using some cheap non-gold
leads.
plated, and you're just like,
Probe suck.
I'm getting different numbers every time. It's like, just
Yeah.
throw those, literally just throw them out.
Right.
Get some real ones.
And see,
'cause-
I've learned over
Yeah,
the years that I do it twice. If it matters, I'm
Right.
going to measure it twice. If I get a different measurement twice, I'll do it again. If I keep getting different measurements, something's wrong with the measurement system. It shouldn't be that difficult. Yeah, and it's with a DMV, that's a cheap.
Well, a lot of times I ran into this years ago. I was measuring
DVM,
I
sorry.
was measuring DC with a cheaper multimeter. It was like a $30 multimeter, but it wasn't true RMS, right? And I didn't know, but this was a very noisy DC source, so it was
fooling the
problematic,
meter.
right?
Yeah.
That it was auto ranging, and it was giving me a number that was inaccurate. And you wouldn't think it would really matter, but in this particular device, it was giving me totally wrong numbers that were off by like 10%,
Right.
right? And this was DC.
Yeah, because the cheaper meters will. The reason they're cheap is because they are, and they're rectifying the noise and adding to the
Right.
nominal DC level. So you're getting an offset from the RF that's being detected where it shouldn't be. There's dioting going on in the circuitry where they could have put probably a 0.01 to ground or something, a cap to
It
get
could be
rid
all
of that,
kinds
and
of
they
things,
just
yeah.
because it's a cheap meter, they
Yeah,
just
they didn't.
You don't
skip
want
all
it,
this
yeah.
shit.
And we're not even
Yeah.
talking like a Harbor Freight meter. Like it was like a decent meter by most
Yeah,
standards, but
right.
it
wasn't made to
high-end.
deal with high frequency
Right, and you
energy.
compare it to a
Yeah.
few other high-end brand name meters, and usually they give you very, very close results within spec. Sometimes meters do not, or any test gear may not give you measurements in spec.
Yep.
Sometimes, and that's the issue.
That's why I'm always amazed using that Hioki
Right.
four wire.
Right? Yeah.
It just bam,
4 lead
Yeah,
impedance
4
measurements are
lead.
just so incredibly consistent. Yeah.
fantastic. Use those.
Yes.
Okay.
Yeah.
Now we really getting into the nitty gritty. See, these are the damn things we got to deal with on a daily basis.
Well, you get screwed by them all the time.
All the time.
Eventually,
Tell me
you're
about
like,
it.
all right, we got to fix this
Yeah,
problem because I
right.
don't want to have to guess and check everything
Yeah.
every time.
Yeah.
So.
Yeah, you got to be confident in the measurement.
Yeah, right. You do. And if you can't be, then you shouldn't be putting it out there. And that's really, really, when you think about it,
Yeah.
I mean, we internalize this stuff because we're not sharing this stuff. This is what we use on a daily basis.
Yeah.
If we're wrong, we screw ourselves.
Well, yeah.
We're not screwing anybody
Right.
else.
Yeah,
You're going around in circles figuring out what's going on here because you got bad data.
Mm-hmm.
And so, yeah, I mean, that's how you learn real quickly. When you start screwing yourself,
Yeah.
you got to fix your own errors,
Yeah, you
and
kind
that-
of get tired of that.
yeah.
Yeah.
And that's what it's all about. It's like minimizing the error.
Yes.
That's it.
That's
Exactly
the hard
that.
part, though. That's the hard
That's
part.
the hardest part. Yeah,
Yeah,
it's a
try and
bitch.
do that.
Error's a bitch.
Yeah.
Thanks everyone for watching. Measurement videos are coming.
Yes.
Take care.